Hey YouTube, I'm doing outstanding and apparently I'm super short. There we go. That's better. Anyway, I'm back in Universe Sandbox 2, but this I'm not in VR. I keep saying I'm going to record VR, but it's it takes a lot of stuff to be able to record VR, and it is like 3 in the morning. Sunday, I really hope to be able to record, and probably will be able to. I just wish things would actually just work out and I wouldn't have to worry about it, but they never do, and that makes me sad. Ooh, God, it gets loud when you get close and bright. I like how you can actually see the brightness on my face. Uh, that's kind of cool, but maybe just to me. I don't know. So, what happens if we take the sun, right? Very fancy piece of tech there. And we change it to one Earth. Things are immediately they just forget the sun ever existed, and they just go off tangentially, I believe is the term. Definitely more noticeable on the inner planets as they very quickly surpass. Like every 15 days they're traveling. Fucking far as hell. How fast is the Earth moving? Average surface temperature is dropping hella fast. Hella fast. 37 kilometers a second. Oh dear lord. That is... I'm surprised Earth didn't really collide with anything on the way out. But it looks like it's kind of frozen over. Humans would still be alive, sure, but it'd be a tough time. 21C. Nah, we'd be dead. We'd totally be dead. Well, what if, at this point, we change Earth to one sun? This will confuse everything around it, but not by much. It's kind of freaking out, though. I can't tell if anything's actually being pulled in. Nah, they totally are. Just very slowly. And like Venus and Mercury are just way gone. Uranus is confused. But for the most part, like nothing seems to care that pretty much what just happened is that it teleported. Now the sun is accelerating. The Earth itself is steady at 30 kilometers a second. But things are changing. Mars is, bending. We're on to a couple months a second here. I wonder if Mars will eventually collide. I don't know. What about Orcus? How is that not accelerating backwards? It's slowing down now. Oop, I just saw something. Alright. 10 suns. That'll make it interesting. I'm surprised that Eunomia is just gliding right there. 20. It is being accelerated, but it's going so close to Earth's speed. That's kind of funny. Interesting. It's like almost exactly parallel or something. Well, not really. It's not even close to parallel, but it's just kind of interesting. Oh, Mars just got eaten. Mars is gone. Ooh, Uranus. Finally get. Now, let's make it more interesting. Now, it was 1,000 times the mass of our sun. How is Mercury still not... You see things are now really getting interesting as mass is literally being pulled from all around. Ooh, something just got fucking shot out of his face. You know, Mia? Alright. Getting interesting. 1906 is coming in. Gone. Not really. It's not going that fast. See, a lot of things are just kind of being shot out. I'm surprised that, oh, it dropped down to hours. Why? Simulation can't... What? Whoa, shit. Okay, now I've lost everything because it just fast-forwarded to years. Right. Now, it's a black hole, and that should pull everything back in eventually. Finish. I don't... Oh my god. It's 31 times the mass of the Milky Way itself. Interesting. Let's change up to simulation. Let's go open. An Alpha Centauri triple system. It's the closest star system to the Sun. The system consists of a binary pair of stars, Alpha Centauri A and Alpha Centauri B, orbited by a smaller and much more distant star, Proxima Centauri. You'll need to zoom out to see Proxima Centauri in the simulation. Oh, wow. Oh, Jesus. It has 1 kilogram of mass. Because I wanted to label the barycenter. Alright, let's speed this up a bit. That... Whoa. Now you can see the stars just... Let's slow it down to just a few months per second. Interesting. But if we focus on the other star... Huh. How weird that would be to see. Like, from this planet's perspective, it would just... God, it'd be weird as hell. That's what it would be. Uh, 853 oceans. Interesting. Well, let's change it to 1 Earth. Ooh, you can already tell its orbit is messed up. Oh, the barycenter immediately got pulled over there. Interesting. Oh, it's interesting. The barycenter is actually... Ooh. I would not want to be that planet. Because it gets accelerated up to like almost 500 kilometers a second. Oh my god. Boom. Whoa. It's getting smaller. They're also being pulled towards each other. I don't know what Proxima Centauri is going to be doing way out there, but... And... Ooh. Wasn't it orbiting BC? Oh god, that would be frightening. It's going so close that the planet's definitely dead. Like, anything on it is fried, but... Aww. Eventually one of them's going to collide in this particular situation. Proxima Centauri is working its way in. Because the fragment has already been accelerated way past the orbit. Oh, that's just heading like straight at him. Oh my god. Alright. Oh, there's already... Oh no, okay, there is. Oh, now they're moving through space that way. Very weird. I know I'm not talking a whole lot, but that's because I'm interested in what's going on there. Let's see. Planets between the Earth and the Moon. So, oh god, that's really hard to read. It may seem hard to believe, but it's true. If you lined up all the planets in the solar system end to end, they would fit between the Earth and the Moon. There is a catch though. The Moon's orbit is an ellipse, which means its distance to the Earth varies. The planets won't fit if the Moon is at its pericenter, the distance at which it is closest to the orbit, in its orbit to the Earth, or even when it is at the average Earth-Moon distance. The distance shown here from the Moon's surface to the Earth's surface is about 393,000 kilometers. This is slightly less than the distance of the Moon at its apocenter, the point in its orbit at which it's furthest from the Earth. Still, there's a bit of wiggle room, as there's a gap of about 1,600 kilometers between each planet, about half the diameter of the Moon. We often imagine the Moon is very close to us, and relative to the immensity of space, it certainly is, but here we can see the distance is still very impressive. The sizes of objects in space are often hard to grasp, but what is even more incomprehensible is the vast expanse of emptiness that lies in between. There's actually another factor to consider here. The planets will fit at the average distance if you rotate them a bit. This is because the planets are not perfectly spherical. The diameter is a bit less if you measure through their poles instead of their equators. In Universe Sandbox, measurements reflect the average diameter, and the planets are shown as spherical. So, It's the Earth, and then that would mean that Moon is all the way out. So that's the actual... Oh my god, that's insane. That is insane. But let's see what happens in the first, few minutes of this simulation. I mean, it looks like poor little whatever that is, Venus is going to be eaten. Jupiter here is probably going to eat everybody. Oh my. It's insane. Okay. I don't see the planets themselves moving, so I'll bet they're locked. Granted, that's hours. Okay, now we're into days and Moon is moving. For sure. Well, the Moon is, but nothing else seems to be. Because I feel like they should have collided by now. Nope. It went on to an auto orbit around something. No idea what those guys are going on to orbit about. Yeah, interesting. Very weird. Very weird. Climate simulation. That's for 9th planet. Total solar eclipse. Earth and a sphere of moons. That sounds dangerous. This is gonna very quickly turn to chaos. Oh, chaos. Chaos. Why is there sound? There shouldn't be any sound in space. It's a lot of damage. Earth is now 1.07 times the size of Earth. 1.08. Also, look at the size of that moon. That's no moon. Poor Earth. Oof. Look at that moon. It's radiating. Oof. That's almost Earth itself right there. Moon 59 is now 717 times the ocean. How much Earths is that? Oh, it's like not even close to Earth. Wow. What about moons? Oh, it's like 13 moons. Okay. That's not what I wanted to see. That's 100 moons. Ooh. One of the moons got sent off. This is Moon 59. Earth is gone. Alright. I don't know what this is. I'm just clicking. In this simulation, 50 asteroids, each with a radius of 20 kilometers, orbits the sun at distances that range from 2 to 125%. The distance between the Earth and the sun. The sun's gravity pulls volatile materials like water from nearby asteroids. The speed of this volatile loss depends on the distance between the asteroid and the sun. Whoa. That looks trippy. Like, they're practically flat from that angle, but, like, from here it's kind of cool looking. This guy's just... It almost looks like it's, like, flat here and then goes up, even though, no, it doesn't. That's gonna theoretically fuck everything up, right? That is 10 times the size it was. Things should be pulled towards it, right? Right. Oh god! Okay, they have to be locked into orbits or something, because, like, it's so much bigger than it was. Okay, there we go. Now it's doing something. Jesus. I don't know. I think that's everything for this episode. Thank you guys so much for watching. Hit that like button, hit that subscribe button, and you have a good one. You have a good one.